Hello, friends of software entertainment, and welcome to a new show, actually with Flow PHP from CSV to REST API. Welcome, Norbert.
Hello, hi Roland.
Norbert, please introduce yourself and what do you do with PHP?
So I'm a software engineer, software architect. I've been building software for at this point, I think 16, 17 years already as a developer. Currently, I work mostly as a consultant. I help companies to build dedicated solutions for their data storages. And help connect them with the BI solutions. I'm also an author and currently the only maintainer of a framework called Flow PHP, which is a first PHP data processing framework strongly inspired by Apache Spark and solutions like Pandas, for example.
So if you have any problems or I have any problems, we can contact Norbert. He is PHP consultant. And Flow PHP, this is your project, and I will share the screen now. Then we take a look what you have done there and what problem it solved and why we all have to use it.
Yes, so Flow PHP has only one goal. It's to unify data processing in the PHP, because software developers who are familiar with other languages like Python, for example, or Java, Scala, they all are very well, I mean, most of them are very well familiar with concept of ETL, which is extract, transform, and load. In PHP, we didn't have something like that. And the problem was that there's not a single solution for one problem. So let's say we need to take some data from the file and then slightly modify it, load it into the database, and then expose it from there. This is just one of multiple scenarios where ETLs are very applicable. The problem in PHP is that we can solve this problem in many different ways. We can, for example, just read the entire content of the file to the memory and then parse it from memory. We can use dedicated functions to read CSV files. Do many other things, but there was not a single tool that would create like a unified interface for this problem, like an abstraction that would be reusable and easier to understand. And that's how Flow started. Like, I've been working on a system that was integrated with multiple other systems, and those integrations were usually APIs, reports, files exchanged, things like that. And what we noticed at some point that every single developer who was working on this project was taking a slightly different approach. And what's funny enough, new developers, when they joined, they not necessarily always followed the best practices. Somehow, I don't even know how this was happening. They were choosing the things that were actually, like, over time we proved that those approaches didn't work, and but still they were replicating that. That was mainly because of lack of standardized approach to the problem. And that's how the idea of creating Flow started. So on the website, you can basically see you can literally start from examples, which explains how Flow is helping in reading, processing, and transforming the data for you. We have multiple examples on the homepage. We can also go to there's also GitHub organization for the Flow. Flow is built as a monorepository, meaning that all components, everything that's part of the framework lives in this one repository. And there are quite few components. As you can see here, we have two core components, which is a CLI application that I'm going to show today. I'm going to present how to use it, but also the core of the framework. We have several different adapters. Each adapter pretty much brings the integration with specific data storage, file format, or just extends the functionality of the framework. There is also a few libraries. Libraries are standalone reusable components that, like for example, Parquet, which helps to read and write a file into a binary Parquet format, which is extremely efficient for data processing. Which also didn't really exist in the PHP. There was one library, but it wasn't really solving all of the problems and was still missing a few things. Plus, it was a direct port from the C#, including the coding conventions, so it's not very. It wasn't very easy to use it. So that's how I started creation of the new PHP, purely written in PHP library for Parquet. And there are also bridges. Bridges are like a connections. They are just glue between the Flow PHP and other frameworks, and that's how we have, for example, bridges for the file system. Because of the nature of Flow, we had to also redesign the new. We also had to create a new abstraction for the file system because existing libraries they didn't give us enough flexibility and enough features that we needed to process the files from the remote locations. So now we do support AWS and all AWS type storages, plus Azure storages as well. So this is more or less how the project looks. We also have a roadmap which we try to follow very strictly. Every 2 weeks there is a new release. All the releases are documented. If you go to the Flow PHP website, there is a release cycle explanation that says how frequently and how exactly are we releasing new features of the ETL, so of Flow framework. So just following this every 2 weeks, and there is every 2 weeks Monday we have a new release. But let's maybe move to the.
Is there so much to do? What are some kind of features or improvements that you have done in the past?
Well, it's quite a lot. I've been building this framework. I think it's been already like 5 years, something around.
Wow.
Almost 6. I think it all started in 2019. Back then, I already worked for a few years with Apache Spark, so I already came with some experience with data processing, especially with like bigger data. And since then, if we take a look at the changelog, it's actually quite long. All of this is the history of how the project was developed from the beginning, including all contributors, all features. So yeah, it's quite a lot. Recently, I've been mostly focused on developer experience, providing new ways to integrate with Flow, working on new adapters. I recently did like a huge refactoring of the Parquet library to make it even more efficient, especially memory efficient, because one of the core principles of Flow is to allow the developers to easily manage the resources they're using for consuming the data. So, but I'm also gonna show it during the demo session that I've prepared.
Okay, yes, looks good. So the decision to make it open source was from the beginning because you love open source, or you want to reach more people, or want to get help from people? I also started a few GitHub projects, and I think I'm the only contributor there, and not so much people are using it. I have some Cypress test-based setup that gives you directly end-to-end tests for any kind of web page. And so why open source?
Why open source? So for me, the open source is a way to just give back everything I took from the community, because everything I've learned from people that were sharing their knowledge, their experience through open source. And I truly believe this is the way for like all of us to evolve and get better. That's why whenever I'm building something that's reusable, whenever I'm trying to solve a reusable problem, I try to share it. I try to give it back to the community. But I also really believe in the communities itself. So like this is the best way of solving the problems, just to solve them together. That's why open source. Also, I've been doing open source projects since, I think my oldest one is called PHP Matcher, or it's a very simple library that you can use to match patterns in PHP. Let me just quickly open it. So this is the library that I wrote, I don't know, like 14 years ago with my friend, and since then this library is being used mostly for testing and matching the patterns against specific values. Very useful when you need to test the responses from the RESTful APIs, for example. So yeah, I've been doing open source for quite a long time, and that's why I decided to keep doing this with Flow and keep building this in public for everyone.
And it's pushing you and gives you motivation, or it's annoying because you have to moderate some people and to tell every time how they do something? And is it more work or more passion?
It's so I'm not getting annoyed by people asking questions. I don't think I ever refused to help someone with his problem. It's like this is what I do. I help people solve their problems. For me, open source is also like it's a source of inspiration. It's like when you are deep in a problem and you are solving the problem, you usually tend to focus on like one specific solution. Meanwhile, people who are not in the same context, not in the same mindset, they may come up with more creative solutions for the same problem that you are approaching. And I've already found out that people that were asking me questions on Discord, because we also have a dedicated Discord server that you can see on the website on the top menu. People who are asking questions there, they are also a huge source of inspiration for not only like solutions, but also new features. Like more exposure to problems gives me more ideas of how those problems can be solved, and also helps me to improve the tool itself. So that's pretty much my main motivation.
Very good. Yes. So maybe we can look at the project and what we can do with it.
Sounds good. Let me just share my IDE. Let me know when it will be visible.
So this works.
Okay, so I've prepared like a skeleton application here. It's built on top of Symfony framework. I believe it's latest LTS version. However, what I'm going to show is framework agnostic. None of this is like, nothing that I'm going to present today is specific for Symfony. This exactly same thing can be applied in any other framework, like Laravel, for example, or like whatever else you're using there. I just decided to go with the framework because it was a bit easier for me to glue all the components together. And let me just quickly explain what do we have here. It's a very minimalistic setup. So we only have
this is just a project from a Git clone.
Sorry?
This is just a project from a Git clone, or
I just started.
It's a Symfony skeleton, yes.
Yes, it's a Symfony. It was created through the Symfony CLI application. Create a new project with the very minimalistic setup. What I have here, it's just few dependencies. So we have Doctrine database abstraction layer with Doctrine bundle and Doctrine migrations bundle. That's important because I'm going to show how to easily generate schema, Doctrine schema, database schema from any file schemas. Then we have a few basics of Symfony console for the CLI application, .f for reading envars, Symfony Flex framework bundle, HTTP client. This one I'm gonna use it to show how to consume like streamed responses from the Symfony framework. And this is pretty much it. I also added Symfony Maker bundle to make it easier for us to create controllers and commands during this session. So as you can see, there is really nothing custom. The only custom thing I've added here is this. So what I wanted is, I didn't want the migrations to take the schema from the ORM, because I'm not using a Doctrine ORM at all here. There's only the database abstraction layer. So what I did is I registered a custom schema provider for Doctrine migration. So whenever this provider will define a table or any other component of the schema, this will go automatically to the migrations, and this is done through the Symfony dependency injection compiler pass. So this is pretty much the only custom thing I did. Everything else is as is. On top of that, I downloaded the Flow CLI application. It's the FAR archive that you can get from the GitHub release page. This is the latest one, and I'm gonna show how to use it through the CLI directly, like here. It's part of the solution for the problem we're gonna try to solve. So what is our problem? Our problem is very typical for pretty much any software that's consuming data from like external systems. What we're gonna do today is we're gonna open we're gonna grab an orders from a file. This is a CSV file, but it's like actually it's just one of the possibilities. We can actually also take them from the APIs, from XML, from JSON, from any other files or any other data source. This is our file. All of those orders are fake orders. I generated them using a PHP library called Faker. So none of this is actual. Those are not actual people data. This is all fake, all generated, just in case someone will be worried that I'm presenting some personal information. This is all fake. I've prepared 3 files. This one is the smallest one. This one, I believe, has only 10,000 rows. It's something that going to be our working file, something that we're going to just work and present how the processing pipeline works. Then I also have one with 100,000 rows and one with 1,000,000 rows. We can pretty much import all of them to see how easily it is to operate on those files. So our goal is to consume this CSV file, but as we know, CSV files, they don't come with any schema, and like any nested data structures in them are a bit complicated, which we can have, which we see here. So this is the structure of this file is more or less like this. We have order ID, we have seller ID, so those are 2 UUIDs. We have the creation date, we have date when the order was updated, date when the order was cancelled. We have some discount, not sure yet what it means. We have also email, customer, address, notes, and items, right? So very, very typical, very, very common structure for any e-commerce solutions. But this can be really anything. I'm just using orders because I used to work really for a really long time in the e-commerce domain, so I'm familiar with it. But it can literally be anything, anything you want. So what's the first thing we want to do? The first thing usually we need to do is we need to understand the schema. We need to understand the data structure of what we are trying to consume, what we are trying to build. Because how typically something like that would be done is like we would need to go to the database, define the schema of the data in the database, and then figure out a way how to process this file, validate it, maybe put some constraints, maybe do some transformations, and then load it into the database. So later we can expose it from this database through our API to our clients, right? So that would be this is the approach that typically we would take. How this can be done using Flow? First of all, what we can do is we can use the Flow CLI application to even understand what's happening with this file, like how does it look. And Flow comes with like few very handy comments, like for example, the one that allows us to read the file schema. Let's try it. So we have Flow file schema, our data orders.csv. Doesn't look very good because by default Flow is exposing the schema as a JSON file. Let's make it look a bit nicer. Let's check what are the options of this command. And we have as an output we can use PHP table ASCII. Let's use this one. It's probably the most readable format. So what happened in what Flow did is like Flow opened this file, iterated through it, and detected the types of the data using some like built-in heuristics, because in CSV format, everything is a string. So everything is pretty much a string or integer. We do not have more advanced data formats. So that's why, as you can see, we have, for example, updated at, created at, cancelled at as strings, not as date types, because this is the nature of the CSV. But Flow is smarter than that, and if we put additional option, let's check what was the name of this option, schema autocast. If we use it with that option, Flow will do a bit more. It will take another step. Flow will look at the format of the data and it will try to match it to one of the existing data formats that Flow recognized. And now the difference is that creation, updated, and cancellation dates, they are date times. They are properly recognized as date times. We now see that the discounts are floats. We see that emails are strings, customers are strings, addresses are maps. So address is pretty much associative array of string to string. Nodes are a list of strings, and items are interesting because they are a list of structures. And what does it mean? It's a list that each element has the following format. So there is SKU, quantity, and price inside of this item, right? So this is already much nicer.
This feature is very good, yes, because I also know a lot of CSV files out there to have a quick view. Perfect.
We can even make it a bit nicer because this only gave us the schema of the file, right? But like usually when you are analyzing something, you also want to know, for example, which columns and how badly they are corrupted, because in the CSV file there is no validation. So like, how can we know how many orders were canceled, for example, and how big of a problem this is? So Flow also has this another option called Analyze.
It's a statistic analysis.
It's actually just iterating through the file and trying to collect statistics of the values in the columns. So what we can get from it is, like, as always, the best is to use the schema autocast. So Flow can easily detect the schema, and we can display columns, for example. So what's happening now is Flow is analyzing the file. That's why I'm working on a smaller file, because in order to get a full picture, we need to analyze the entire file. Of course, we can limit those options. We can tell them what's the maximum limit of the rows you want to read from the file. But what we can see here is that we pretty much have order ID, and there is 10,000 unique values here. So we know that each row is unique. So this will be our, because we know that the total rows is 10,000, and now we see that.
Can you try to make with Control Plus or so that maybe the terminal is getting something bigger? Maybe with Control Plus just?
No, but give me a second. I'm going to see if there is an easy way to.
PHP Storm settings are nothing easy.
No, it's a lot of settings. But wait, terminal. Oh, I think I found font size. Let's make it 16, for example. Is it better now?
Yes, it's better now. Thank you.
Okay. So we have order ID, which have 10,000 unique values. So we can fairly assume that this will be our unique key. We also have seller ID, and now we see that there are only 5 unique values. So we know that we are talking about 5 sellers in this, 5 different sellers that were selling those items. We also know that looking at this, that like at least half of the orders have updated at. There are like some orders without created at, which is weird. That shouldn't happen really. So maybe some corruption in the file. We see that around half of the orders are not discounted at all. Already gave us something, some knowledge about this file. And here you can also see, like, when we're talking about strings, that email is like maximum length is like 36. The customer is like 23 characters. Might be useful when we're gonna build the schema for it. But like, so we know the schema of the file. We have the file. We understand it. Now, what would be the easiest way to put it into the database? What kind of database we're going to use for this example purpose? I decided to go with the SQLite database. So in the I'm just going to create the database in the folder of the where the data lives. Normally, it can be any other database. It will be perfectly fine. But how do we do that? First, we need to understand. First, we need to define the schema. So what we would normally do is we would go here, and the schema object takes tables, where we can pass the doctrine.dbl definition of tables we are creating, right? Is there like any? Normally we can type it by hand, but what we can also do with Flow is we can do this. Schema data orders CSV. This will give us schema in the JSON, but we can do output PHP. And now Flow created for us the schema created as the proper schema. However, it still recognizes those as strings and JSONs. So schema autocast. Oops. It will take him a bit longer, but now it's properly recognizing those schemas as map, lists, date times, and more precise formats. What can we do with that? What I usually do is I put it somewhere into the static data factory. Let's call it data frames. I'm going to explain in a second what data frame is. And let's call it orders. Something like that. Okay, schema. Now what's happening here? So we don't have yet any. We don't yet have the project dependencies. So I'm going to need to bring. I'm going to need to bring the part of the flow to the project so we can even use it. The main one, the core dependency, is the ETL. That's how you bring it. You just do composer require flow PHP /ETL, and now our project already have the schema, all the and all the functions. I'm also gonna use. I've prepared. Oops, sorry, I forgot what was the comment that I scripts. No, there's this project is actually using Rector, so I think it will be like this. Rector, yes. So I used Rector to remove the to simplify the imports.
Yeah, nice trick. Yes.
Sorry.
Nice trick.
Yes. And now everything is properly imported to the project. I'm also going to clean it up a bit quickly because this is like just auto-generated. It's those empty metadata. This empty metadata is not really useful for anything. So we have the schema, right? So we have our schema, but how do we add it to the database? How do we make database aware of this schema? We need to put another dependency that Flow comes with. We need to create include the doctrine adapter into the project, which will give us a few nice features. It also comes with doctrine.dbl bulk library. This library is responsible for like saving data into any database in bulks. So it supports inserts, updates, and deletions, but also upserts, insert or update. And on top of that, there is an adapter. So now when we have this, what can we do is we can go here and we can use to DBL schema table. And now what we need to do is we need to provide flow schema, orders schema, and we need to provide the table name, which will be orders. Okay, now what we can do is we can do this. Console. So what happened now is this function called, because Flow is built to improve the user developer experience. Flow comes with the DSL, domain-specific language. This DSL is represented as very simple functions, but under the hood, those functions are actually initializing objects because Flow is built in like object-oriented approach. However, to simplify the pipelines specifically, we also came up with this simplified DSL version that improves the readability of the pipelines, but we're going to get into this. So now we have the table, we have the migration that, excuse me, that will generate, that generated can be generated through the migration. That's how it looks. So now what we can do is we can do so doctrine migration migrate, yes. And now we can check if the database was properly created for us. Refresh. Yes, we have our orders, they're empty, there's nothing here, but we created it. So like this was already quite automated. We didn't have to manually type anything. We didn't need to have to check anything. All of this was so far pretty much automated by the Flow, including the examination of the schema and generating the schema definition in the PHP. But we have a schema, we have a database. Now we need to build something that will help us to move the data from the file into the database. How do we do that? I'm going to use the Symfony maker bundle to create the, I think this was the, sorry, command. Command, and we're going to make it up orders import, for example. Okay, so our command should be created already. Yes, we don't need any options for now. We can remove that. We don't need this. We don't need that. Okay. Let's check if our command works. It will be here, app orders import. Yes, our command works. It does nothing. Let's just add importing orders. Okay, we have a command. So now how do we even approach it? So the entry point to the Flow is a function called data frame or df. But before I show it, let me maybe just very quickly explain what the data frame pattern is. I've prepared this like short markdown explanation for the data frame. And we can imagine any data set as something like this. It's pretty much a table. You can think as it as a Excel table, for example. We have columns with some headers and then some data. What the data frame does for us is like data frame iterates over the data set using just a chunk of it, so at time. This is a technique allowing us to process massive data sets, reducing the memory consumption to minimum. The memory consumption is pretty much defined by the data frame size. So if our data frame size is 1, we're just going to iterate through the data set row by row, right? If our data frame size is 2, we're going to iterate by 2 rows at a time. And this is pretty much it. It's just the size of the window that is being used to iterate through data set and perform the operations on it. And this is the foundation of the Flow. This is how Flow operates. Flow is built on top of one of the nicest features of PHP, which are the generators. And thanks to them, we can constantly read from the file, yield the results, operate on them, transform them, load them, and keep doing this even on files that normally would not fit into the memory. This also helps us to keep the memory consumption very low. So let's get back to the comments. How are we importing it? We need to start the data frame. It also takes some configuration options, but this is a bit more advanced. We need to read, but from where are we reading? And here is the thing. We cannot read it from the CSV yet because we don't have the CSV adapter that's bringing all the nice extractors. So we need to add to our project the CSV adapter. What happened here? This happened. It couldn't clear the cache. Right. So now we have the CSV adapters, and all adapters are listed on the Flow in the Flow documentation in the installation section that you can find on our website in the documentation section. So how do we do it? We read.
So now it generates also some files in background, or what happens?
No, nothing is yet being generated. No, it's just this
Dependency.
It's just a dependency, exactly. Like
Okay.
nothing happened in the backend. We just installed the extension for Flow, allowing Flow to properly recognize and read the CSV files. That's
Okay.
what that's for. How do we do that? So there is this from the copy reference, absolute path. I'm not gonna use any options, of course, this is not the best way of providing the paths to the files, but I'm just gonna use an absolute path for this example. Normally, we would use this kernel.project directory
file directory
from the Symfony, but I just don't want to confuse anyone with this, so I'm just gonna put an absolute path. And what will happen if we're gonna execute this command now? Absolutely nothing. Why? Because Flow is lazy executed. This means that nothing will happen until you do the command, until you execute the one of the trigger methods. Run is one of them. Run pretty much tells the data frame to go and do something with the data. But at this point, there is nothing yet happening, so we won't see anything. In order to see something, we actually need to do, we can do, for example, write to output. And what will happen now is that Flow will, what happened here? Data frame run to output from the CSV. Of course, this is the live coding, so something has to go wrong.
We want to see professionals how they debug. This is one of the most important things.
What's your favorite?
To see debugging in extreme situations is the best knowledge for everybody out of there, to see your little tricks how to make something run.
Totally. So let's first try to figure out what's even happening and where we are getting with this. So yeah, we are getting here, we are getting here, and we are getting here. Okay, so we are getting somewhere. Let's see if this file even exists. And this is the most advanced PHP debugging technique called var dump and die that I'm using here. Of course, I'm joking, and of course the file. I
use var dump and exit and have a little live template for it.
Yes, there are also those handy functions with like dd dump and die. What was wrong was the data. I used docs instead of data folder, so that was really wrong with the. Yeah, now it works. But what we see here is not very useful. So maybe let's remove that. And as we can see, Flow iterated through all 10,000 rows and printed them on the to the standard output. Also truncating the values of the columns to keep them visible. What we can see here is that each column is each row is like a separated table. And this is what I've meant with the data frame. How do we change it? We can do something like that, batch size, and we can tell him to process in batches by 10. So now it's processing by 10. This means that at one point in time in the memory, we only have 10 rows. And I guess you probably can see the pattern here. More rows we're going to put into the memory, bigger memory consumption will be, but quicker the operation on this will be, because we're going to operate in memory, which is the fastest way of like manipulating the data. We can also put some limit. I know, let's say we just want to analyze first 500 rows to make it faster for like development, right? So now we only have 500. We can even pretty much set 500 to load them in memory. This will take longer. It's the memory consumption will increase. But like, how can we even know like what happened, how long it took, like what's happening here? So Flow has this also very nice thing called it can collect analytics. You can pass an option analyze, which is a second argument of the function run, and now we're gonna get a report. So what can we expect from this report? I've prepared to not type it from hand. I've prepared like a very nice summary, and now we can remove this and do something like that. So Flow analyzed the file. Execution time was like less than a second, like not even a second. Memory usage was 8 megabytes. Not too bad. But let's also do something. IO progress start. Let's start the progress bar and let's use it here. IO progress advanced. Okay, auto completion never works as it's supposed to. And let's finish the progress finish and then IO new line. Okay, that's way better, like a bit more interactive. Now we can see that something is actually happening. So we can now read. We know how fast we are reading it. We can modify the batch size to say how many rows at a time we're gonna read. If we increase it by 1,000, there should be just a bit faster. There should be only those 10 steps in the progress bar, and this is the very minimalistic. As you can see, the memory usage increased when we reduce it to 10. Memory should dropped by half. It's very hard to estimate how much memory you're gonna use just by selecting the number of rows, because the memory is not only affected by the number of rows that are held in the memory, but also the number of columns. So if you have a data set that comes with 100 columns, naturally it will take way more memory than if you would process the data set like this one with maybe 10 columns. Okay, so we can now read the file. How do we write it to the database? And Flow also comes with a very handy feature for that. So we do write, and the DBL adapter that we installed previously has this to DBL insert. Come on. Sometimes I feel like the auto-completion is working against me, not with me. What do we need here? We need a database connection. We need to know the name of the table, and we need to provide some options that will tell the DBL bulk library how to upsert those rows into the database. Because what we want to do is we want to upsert them. We want to be able to execute this command as many times as we want, and whenever it will be executed and whenever something will be added to the file, we want this to be inserted to the database. Or when something was edited, like for example, I don't know, we changed something with one order, we want to update the existing row. That's why we're going to use a technique called upsert. But how do we do it? First, we need to get the connection to the database, which we can get through the auto wiring in Symfony, like this. I read only, and now we can pass it here. This connection. The table will be orders, obviously, as we have it here. We can also put it the constant, like const table orders, and now we can use the constant self table const, and here we can also use schema provider table orders. Let's just import schema provider. And now we need to provide also some options that will, it was like this, and SQLite insert options, because why do I need to use a specific options for specific database engine? It's because different database engines, they will come with different options. So some of them will have different configurations. All of this is documented on the Flow website, but you can always get into the source code and check what do we have here. For the only important part, for the only important configuration is this config columns, which will pretty much tell the bulk library which column is being used to determine if the row is already in the database or if it needs to be inserted to the database. Now we can get an error. No such column as ID. Of course, there's no such column as ID because our column is called order ID.
Yes.
Oh, and our column doesn't have a unique constraint. That's why the bulk library cannot actually do insert or update. How do we define those specific configurations for columns? So let's go back to the orders, to the schema. So this is the schema that we get from the file. So this is our source schema. Right, but what we want to get into is our destination schema, which usually will be a bit different than the source schema, but not in this case. In this case, at least at this point, our destination schema is exactly the same as source schema. So what we can do is we can just do something like that: order ID, metadata, DBL metadata, primary key. What will happen if I'm going to use this? So I'm going to go to the schema provider. I'm going to use destination schema. Let's just drop this entire database. And I also prepared this like composer db reset command that will do exactly the same thing. There are no migrations, so it will not reset them. So what happened now is thanks to providing this additional metadata from DBL metadata helper, thanks to this, we pretty much told Flow that this column in Flow schema has also additional metadata that the converter that's converting the schema from the Flow schema into DBL schema will recognize and will mark this column as a primary key. And we can see it happening here. So there is a primary key added at the end. OK, so our migration was generated. Let's migrate it. And let's check the import command again. Voila. Now we imported those 10,000 orders into the database. Can we do it again? Of course, we can do it as many times as we want.
I need some soundboards, like an ice hockey when you hit a goal or something like this.
Why memory usage increased from those 8 megabytes to 42 megabytes? So what's happening? Flow is also trying to predict, trying to optimize the pipelines because it's not very efficient to load data into any database row by row. When we are importing 10,000 rows, the worst thing we can do is we can is just do it one by one. So if we would do something like that, batch size 1, we are pretty much telling Flow just do it one by one. And as you can see, this is taking significantly longer than it was before. So what's happening? We never provided anything. We never did anything, but Flow anyway detected that something is happening and it's changed the default batch size. So what's happening here is Flow is trying to analyze the pipeline. It's doing very similar steps to what database engines are doing, just in a very simplified way. So it's before you click run, Flow is analyzing the entire pipeline that we've built, and it's checking if the batch size was configured. If it wasn't, and it's going to write into the storage that is designed to receive data in bulk, then it will automatically, by default, set it to 1,000 rows. That's why when we don't set anything, we are actually getting 1,000 batch size. But we can also play with it and do it like 5,000, for example. So now it will load it in 2 batches pretty much to the database. Memory consumption significantly increased. Execution time is still acceptable. It's still like below 1 second, a couple hundred milliseconds. As you can see, I was importing, I was doing this multiple times. the data, no errors. We loaded all 10,000 rows to the database, right? So this is how easy it is to add something to the database.
So it checks actually UID and data, and so will it also do some updates or kind of difference when you have maybe new information in one line to
Yes.
existing?
If you change
This is
something,
spectacular, yes, when it's working out of the box.
If you change something here, like let's say there is this, or like let's change this person name to person name. Let's re-import it again, and let's try to find this order in the database. We should see that order ID. We should see the updated version. Yeah, it's now person name, right? So this is how upsert. This is how easily the upserting and bulk updates became with Flow. As you can see, I was like mostly talking, and there is like very little code. Also, this code is like very standardized, so like you don't need to be an expert in like any of the data formats. You just read it like that. We start a data frame, we read data from the CSV file, and then we write data to the DBL table, doing the insert, having the config column to be order ID, and then we run it. We also want to collect some analytics. Then we get a report. And this is our report. This is how easy.
And the report can also say maybe how much is updated, how much is skipped.
Yes.
Deleted.
In report, we can report comes with like various different data, like for example, total rows that we processed, execution time, memory, but also we can collect some data about the columns. It's a very similar mechanism to what I show in the CLI, but you need to enable this with collect column statistics, collect schema.
Okay.
It's because like you need to use those. It's because
the target is performance, yes.
Exactly. You don't want to calculate the statistics of all the columns on the fly. Like this is not very efficient. Normally, you do it only when you are like analyzing something, or if the analysis is the goal. If you just want to analyze something and display it, then you want to use it. But what else can we do? How? What's the true power of the ETLs? So if we take a look at the database, we will now see that our data is here, but we have those JSONs, right? And like
that we
SQL,
make a relation table. Yes.
Yeah, I don't like it that much. I don't like those JSONs. It's not PostgreSQL. When we can actually query by the JSONs, we can put indexes on them. Like this is just a text. So what can we do here? Let's take a look at address, because it's a very simple data structure. What I would like to do is I would like to create a columns with like each of those, right? So street, city, zip, and country. I want them to be a columns, and I want to get rid of the address column. How do I do that? So Flow comes with this on the fly address ref. I'm going to explain in a second what I am doing here. Expand. And just for now, because we are going to a bit play with it, I'm going to do limit 10, and we're going to do write to output. Let's do this. Just maybe unpack, right? Yes, sorry, I used the wrong function. There are two functions, unpack and expand. Expand is for like expanding lists. So like each row of the list will become a new row, and unpack will just unpack structures into the columns. All those functions are documented in our documentation. But what we are doing here, we are telling Flow that to create new entry, new column, we can even call it differently, because when we use the same name as the column we are operating on, it will just replace it. But like let's do it like that. Let's call address. Let's do limit 1, because this data set is exactly the same always. And as you can see, we have the old column address, but we also create new columns, address with underscore address at the beginning. This is how Flow works. This is how you create new columns from existing columns. This is the first first transformation we are doing here. But this is not great. We have this column, we have those columns, but we also have the address column. What can we do? Similarly to the SQL, because most of the data frames, APIs, they are like aligned with the SQL, we can pretty much drop something or just select something that we really want. So in this case, we want to get rid of the address because it's no longer useful. So the address disappeared from the list, and we only have address street, address city. But like, how do we deal with this? It doesn't look good. I would like this to not have the prefix address dot. So what we can do is we can do rename each, and then rename replace, and then look for address dot and replace it with nothing. What we're gonna get here is street, city, zip, and country, right? All good. Almost done. Now we are happy that we have a new data structure, new schema. Let's try it, and bam, it doesn't work. Why? Because our database is not prepared for that. That's why, if you remember, at the beginning I said it's actually not a bad idea to separate source from the destination schema, because here what we can do is we can do that. We can remove the address because we don't have it anymore, and we can add few. So we can add string schema for exactly for what? What exactly do we have in the address? We can see it here. We have street, city, zip, country. So let's do it. Street, city, zip, country. But that's not enough, because if we're just going to use the string, the database will create it as a text, and this is not the most efficient format, since we know that there is a limitation of how long the street name can be. So let's put metadata, and let's do this auto-completion is terrible. About metadata, and let's make it, I don't know, like 248 metadata, and then city, let's make it 512. And then zip, let's make it 32, and country, let's make it 128, should be fine. So this is our new schema, right? Updated schema. What we need to do now is we need to regenerate the schema, actually create a new migration. And as you can see, this is there's going to be a new migration. Oops. What happened here? Orders street cannot be null. Of course, it cannot be null. So because we didn't have it before, and now we are creating new one. That's why it's complaining. No, we could add here a nullability, like the second parameter defines and the schema defines if it's nullable or not. But it's since we have just since we just started working on it, composer db asset. It's just easier to do that. I just removed it. I'm gonna remove those migrations, and I'm gonna generate them once again. And let's bin. So yes, let's migrate. Let's refresh this database. Okay, so now we see that we don't have an address anymore. We have street, city, zip, and country, right? So now we can get back to our console application, and we are done. So what happened here is this was the first transformation that we did. So we loaded it from the file. We transformed it on the fly, and we stored it in the database, automatically also creating the entire schema and the entire structure of our table. And that's how we import data. That's how easy it is to import data, manipulate it on the fly, do whatever we want. And Flow comes with this concept of scalar functions that are being used to manipulate data. So a ref is a shortcut from reference, and the way how it works, the way how you can imagine it, is you need to tell Flow what column to create and from what. You can use literal values. You can add new column by doing something like that with entry new column, and you can do lit. So every row we just get new column with literal value 1, 2, 3, 4, or you can reference to any other column, like let's say email, and you can do I don't know, like any operation. And if you type the arrow, your IDE will show you all possible functions, everything you can do with this reference. You can also build your custom Scalar functions. It's all documented in the documentation. So even if something is not provided by the framework itself, you can pretty much extend the features of the framework by creating your own Scalar functions. But let's move to the streaming part. So we have the database. Everything is in the database. How do we expose this? How do we expose this data to our users? Let's create a controller. Bin console make controller. API controller. Yes. No, we don't need PHP unit tests. I mean, we do, but like this is just an example, so we can skip it. Okay. How do we test it? So I started this Symfony server here, so it should be yes, it works. So I just used curl to check if the URL works. I'm not setting up any proxy. I'm not using the domain yet. I just want to see if the controller is working fine. Let's get rid of this. API, and I'm just gonna copy paste a piece of code from the documentation because I don't remember from my head the streaming component. And then we're gonna look into this and we're gonna adjust it. But before we do that, of course, we need to provide. We need to install the proper bridge, the proper adapter. It's a Symfony HTTP Foundation bridge. It creates this HTTP stream functions. So what we are doing here is we are reading from the. No, we are not going to read from the CSV. We could, technically speaking, read from the CSV and just stream it like that. Also, the response flow, streamed response. Okay, technically speaking, we could read directly from the file and expose it like that, and that would work just as well as any other option. But actually, let's do it. Let's do JSON. Let's do JSON, but in order to do JSON, we also need to have the JSON adapter. This is pretty much how we can expose things from any data source. So what happens under the hood is this just creates a streamed response. It's the Symfony streamed response that's also available in the Laravel. So if you are on the Laravel, this should work out of the box, but I haven't tested it yet, so someone would need to test it and let me know if there are any issues with the Laravel framework. And how do we do it? We pretty much need to tell the we need to read from DLL. And how do we read from the database? There are a few options. There are two ways to read big data sets. We can just use DBL query, that will just read the query. We can use multiple queries, but my favorite one is the key set pagination. There is also limit and offset, which is not very efficient when you are paginating over usually about 10,000 rows in the database. Let's look at the key set pagination. Okay. What key set pagination is even. I also have this like another very short explanation what key set pagination is, just for us to understand, to be on the same page. So let's imagine that this is our database table, right? And now we want to read data from this table in chunks, just like we've been reading it from the file. It's a very similar. It's also like a type of the data frame. So what we want to do is we're gonna read the rows from the table where ID is greater than 0 and limit is 2, right? This will just give us first 2 rows. How do we get to the next 2 rows? Is we are reading from the table where ID is greater than 2 and order by ID and we order by ID, so we keep the same order, and we also do limit to, and then we just keep increasing the key column value, and that's how we iterate through the entire data set. This is much more efficient because it's utilizing the indexes for the fast lookups, and also database doesn't need to calculate the total number of rows. With larger tables, this operation is becoming more and more expensive. That's why when you are paginating over the APIs that returns more than a couple thousand rows, you can notice that every next page after reaching certain point is going to be slower. It's because of this computation that database needs to execute really without any good reason. When we are streaming, we are not really interested in the pages itself, because what we're going to do here is we're going to expose this entire data set as is from the database directly to the client, so client can read it during one really long connection, but also in chunks, so it's not going to consume too much memory. Okay, so let's go back to the controller and let's look what do we need from this. What this needs to. Of course, we need the connection. So function instruct connection. This connection. What else do we need? We need query builder. So this connection, create query builder. Select, let's do everything from schema provider, table orders. And that's it. We don't need to specify anything more than that. And now the key set pagination. Key set pagination key set. And now we just need to choose which column we're gonna use to paginate over, and we're gonna use created at. So pagination key set descending, created at, and maybe order ID, for example. Okay. Orders JSON.
Just only the order ID.
As a second parameter for sorting, because what's happening is this is how it's going to be sorted. It's going to be sorted by the created at,
yes,
but in case.
Okay.
Yeah, in like some edge case situation that there will be two orders created in exactly same second, a second parameter is providing a proper order, which helps us to avoid situations where, because of how database is slicing the data set, to have duplicates over pages. This is the way to avoid it. But it will also work without it. How can we test it? I've created this simple API client script. It's based on the Symfony HTTP client. It's pretty much going to hit the API. First, it will create a file. It will open a file handle, and then it will hit this API, and it will stream the responses. It will take content in chunks, and it will keep writing it until it gets to the last chunk. That was quick. As we can see, it consumed in the peak 1.6 megabyte of the memory. The user was 0.8. And what did we get? We got an error. What's happening here? Let's see. Unknown column type, order ID. It's because. Okay.
Maybe spelling.
No, it's. Try to do it without the first. Yeah. I think the problem is that it was having a hard time while reading from the database to convert it to the UID. I think I didn't check it properly with the SQLite. But it's fine. For this example, this data set is not being changed. It's not changing, so it's all good. I assume this is the issue with types in the DBL register. I would need to look into this. But what happened here is we just streamed the entire content of this table into here. What can we do with this now? We just exposed everything. The client iterated over it, downloaded it. But what can we do? Normally, we probably don't want to expose like things like, I don't know, PII of our customers. So what we can do is we can do something like that. We can apply some dedicated transformations on the fly that will be applied on this dataset while it's being streamed to the user. And one of the cool transformations we can do is masking the columns. So if we do customer, now what we should get is customer field being masked. And you probably can already see that, like, depends on the options, depends on the context, who is asking for a report. This can be programmatically configured to do something with the data. And we can register any type of transformation. This means that we can transform this data in any way we want. Also, we are not limited just to the JSON. We can also download this as, for example, XML, because why not? The only problem is that we don't have the XML adapter yet, but I'm going to fix it in a second. So I added the XML adapter. I'm going to import this function. And here I'm just going to tell him to download it to the XML file. There's the XML. And let's see what will happen. And we got our XML file.
Wow. Spectacular.
You prefer CSV file, for example? No problem.
CSV to CSV.
That's actually CSV to the database and to the CSV.
But we have mask data.
Yes, and there is a mask on top of that.
Nicer data.
So it's like it's clean data, right? So this is pretty cool. And we also can do it to Parquet. How do we do it to Parquet is we need to...
I do not know Parquet.
Parquet is a binary format. It's a columnar format. Very good at like storing huge amounts of data, reading data in parallel, compressing data. It comes with strong schema validation. Parquet is pretty much a database in one file. That's how you can think about Parquet. And I really recommend anyone who have never heard about Parquet to visit the Flow PHP documentation Parquet section and read about it, because it's very commonly used in like big data and processing data, and in general in data engineering. For example, the framework for Apache Spark called Delta Lake is using Parquet as their default format, as many others do, for example. So we can stream the Parquet output, and we can stream it to the Parquet file. The only problem with Parquet files is that
I cannot open in PHP Storm.
Yeah, you can. I mean, you can kind of, and it will work if you have proper extensions, but it's a binary file format. But that's why we have Flow CLI. Flow CLI also have a very cool way to read Parquet files, including reading the metadata of the Parquet files. So now we can, for example, check what columns do we have there and what page headers. Let's start from the columns. So we can check the structure of the Parquet file, but we can also read the Parquet file itself. Okay. So this is how easy we can.
Yeah, it's easy when you have this experience from you. You're super fast. Huh? We have to. Normally, we need maybe 4 sessions of this was included in this session.
Yes, I would like normally. I also provide trainings and workshops for developers. So if anyone is interested in implementing ETLs and data processing pipelines in his organizations and propagated across his teams, I'm available to hire to show everyone how to do it. But all of this, every single thing I said is also covered in the documentation. So like you can go online and just educate yourself from the documentation. I believe I've put a good amount of examples on the website that should help building the very first data processing pipelines. what we can also do with the ETLs is, because we've been working on like writing to the database, but like why limit ourselves? Let's write also to to the JSON. Where are we gonna write to the JSON? We're gonna write it here. Orders JSON, because why not? In console order up orders import. And now we also have those orders in JSON. So we are reading from one source and we are writing immediately into two different destinations. But this is, we can pretty much go to any destination that's supported by Flow, so it will work. This one will not work as is, because I forgot about one thing. In the database, it's doing the inserts. But what about the files? When the file already exists, Flow will try to prevent overriding this file unless we tell him that the mode is override. Then it will just keep recreating the files. I mean, technically speaking, it will first create a temporary file, it will finish writing into it, and then it will remove the original file, renaming the temporary into replacing the temporary with the original one. But now we also have XML, JSON. We can do it with all possible formats. We can do it with Parquet. We can write to any storage that's supported by the ETL. And this is the true benefit of using tools like Flow. You no longer depend on the developer's knowledge about how to write efficient data processing pipelines. You do not need to expect from developers to understand it. Flow under the hood will take care of them. It will divide files into the batches. It will make sure that the files are going to be generated also in the batches. It will make sure that the memory consumption is very strict. We can also do another cool thing here, because sometimes when we are reading files that we are not very sure about the schema, we can also tell Flow to actually validate the schema. How do we do it? We just need to provide Flow's schema that we are interested in just before we write. Right? So here we are doing some transformations, and now we want to make sure that this schema is actually a valid schema, and this one is not. Something is missing here. Schema validation file, schema mismatch, expected. I'm not really sure what's happening here. Let's simplify that. Okay, this is working. Most likely there is something that items. I know why. Because I forgot about this autocast. Sorry, actually no. What I forgot to do is I forgot to tell Flow that when he's reading from the CSV file, he can use schema with schema and orders source schema. Why? Why this is important? When Flow is reading the CSV file, it's not guessing the types. That's why when we read it, it was recognizing items as JSONs. It was recognizing nodes as JSONs instead of lists. But now, when we have the schema that we extracted from the file using the CLI app, when we tell it to Flow, when we pass it to the extractor of the CSV, Flow will automatically convert it without doing this heuristic, without doing this check, without checking the format of the file. Alternatively, we could also use autocast here, and it would work. But providing a schema when it's known is a much better practice. And now the validation is passing, right? So now we also have a validation. Let's see if this validation is actually working like as we expect. Let's maybe remove the order ID, which is a mandatory column. Yeah, and as we can see, mismatched definition. We are expecting order to be unique identifier, but we got nullable unique identifier, which is not ideal. So the validation works. If that's not enough, if we still need to put something more, let's put some constraints.
Can we also say when the data, when one data is incorrupt, that we skip it?
Yes, we can also put conditional validations. For example, we can do conditional transformations. So let's say with entry, and that's a very interesting question. Let's reproduce this example because this is the data normalization and data curation. So let's remove this order. Let's keep the destination, and let's also put a constraint that will make sure. I'm just removing this for now. Let's put a constraint that will make sure that every order ID is unique, right? So let's check if it works. Let's duplicate this for a second. Bah, it's not unique. Okay, in row first, good. Now it should work. No duplications. Now let's remove it. We are having a schema mismatch. How we can fix it? We can fix it like this: order ID with entry. Actually, we want to filter. We want to filter everything that ref order ID is. And we imported 99999 to the database, skipping the one that was problematic. That's what we can do.
Oh, very good.
Like, think about data frame as like SQL. Like, you can do pretty much everything you can do in SQL. You can filter, you can join, you can match with the schema, you can pivot, you can group, you can aggregate, and many more. Like Flow is currently very aligned with the SQL. So if you understand SQL, if you know how to do something in SQL, you're most likely going to know how to do it in Flow. The only complication is that you need to get familiar with the DSL of the framework. But as a good part, as a benefit, additional benefit, is that the moment you learn Flow, you actually learn Apache Spark and Python Pandas and everything else, because most of those frameworks, most of those data processing frameworks, they are built in a very same way. So they use very similar APIs, very similar function names, and pretty much very similar concepts.
Okay, yeah, so that was much. Yeah, I am totally impressed by this awesome tool. You have many years of experience and many developers work on it, and so you have a lot of spectacular features. Thank you for this great overview and this practical deep dive.
Thank you very much for having me here and giving me this amazing opportunity to present the results of my work, mine and all the contributors, which I want to thank you very much, because without the contributions from external people, I wouldn't be able to keep building this tool.
So I end the screen share. Yes, and I think you do a lot of new features, and you are every time invited here to present new features from your spectacular Flow PHP package or other things you make.
Thank you very much. I'm gonna keep that in mind, and whenever I'm gonna come up with something new, like for example, I'm also working on like parallel processing that will help us to process insanely big data sets in parallel. And when this will be done, I'm definitely gonna try to present this feature through your channel.
So, how was it for you on YouTube with me?
Oh, it was a new experience. I've never before been on like a live stream, so this was it was completely new. It was very nice. I'm very excited about this, and I hope this very short session will help people to discover ETLs and start standardizing and unifying their approach of data processing in the PHP. Because I truly think that PHP has it's not really like I don't understand this concept of like, oh, we can only process data in Python, we can only process data in Java. No, we can process data in any programming language, including PHP. PHP is as good as Python. It just has less bindings to external C libraries. That's what it is.
So for you all out of there are watching over 100 people, by the way.
Oh.
They are not commenting very much, but they are still out there. Share it, like it, ask questions also in the comments later. Contact Norbert for any questions. Go to the Discord channel, make issues, try to make any kind of pull request, try to start with it. I also have this little CSV importer for cars from mobile.de and see a chance to maybe go forward with it. Maybe I do not get it directly in my Symfony project, but I have some data for some playground, and there is a lot of CSV examples out of there where you can start with anything you want. So this was a blast for me, and I'm totally motivated to do more with PHP again. And yeah, so I think we say goodbye to the community, and after this we will make a little call or stay in here to see how we can go forward. So for you now, here are 2 videos that you like, follow the channel, and bye.
Thank you, bye.